My name is Pip Smith. I'm the Business Development Manager at CADDS Group. And this morning we're going to be unlocking the future of additive manufacturing in mining. We are coming to you live today from the CADDS Group head office in Henderson, which is south of Perth in Western Australia. So I know that we have a couple of people dialing in from all over. So that's where we're at. And just before we start, I just wanted to acknowledge that we are coming to you this morning from Noongar country and recognise the elders of the Noongar people, past, present and emerging, and also pay our respects to anyone else dialing in from any other countries around Australia also. So we'll kick off by introducing who we'll be hearing from today. Obviously, myself, Business Development Manager at CADDS Group. I think I've been with the business about 15 or 16 years. We've also got from CADDS Norbert Babaram, who is our Product Design Manager. Anthony Snowden is our Principal Engineer and our Engineering Manager, and Chris Edwards as well, who's our Fabrication and Workshop Manager. Then from Markforged, we have Richard Elving, who is Senior Director of the APAC region, and Michael Tuckey, Applications Engineer and Field Support. Then later on, we've got David Martin, who is the Director of Emerging Industries and Innovation, dialing in from the East Coast from the Australian Industry Group, or the AI Group. And just quickly running through the agenda, so we'll have a brief introduction to CADDS Group and Markforged by myself and Richard, respectively. Then Richard and I will have a quick discussion on how the landscape of mining is changing. We'll hand over to Norbert, who's going to be discussing applications for additive manufacturing and mining, specifically two case studies that we've recently completed, or one's still in progress, I think, of products we're developing with mining applications to meet requirements that have been presented to us on site. Michael from Markforged will also join that discussion to talk about the role additive manufacturing is taking in shaping these products. Then Anthony and Matthew Reid, our student engineer, will be talking about first principles and engineering verification. So we'll be providing some technical oversight on printed material testing being undertaken by our engineering team that enable us to independently certify our printed designs. We're pretty excited to share that with you. And then finally hear from Chris from our fabrication workshop on the test work that we've been doing on weldability and strength of printed components. So just ensuring the confidence of additively manufactured components is per current expectation with traditional fabrication options. And then lastly, we'll hear from David from AI Group on digitisation, decarbonisation and diversification. Say that 3 times quickly. So that'll be a discussion on understanding net zero and impacts to the business and industries that we all operate in, from David dialing in from East Coast. Then finally, we'll have a bit of a Q&A. So if you do have questions as we're going, please do post them in the chat. And then if we run out of time, we'll still collate all the questions and circulate the answers to the group as a whole. Awesome. All right, so just a quick introduction about CADDS Group for those of you that may not have heard about our business before. We're a leading design and engineering company that provides innovative solutions for various industries. So we were founded in 1993, a sole owner doing contract drafting on a Rio Tinto mine site. And since then, we've grown to over 200 employees across 7 divisions and workshops in Perth, the Pilbara, Melbourne and Manila in the Philippines. We're a diverse team of engineers, designers, draftees, project managers, surveyors and sustainability consultants, and we work together to deliver high quality outcomes for our clients. Our offering is broad by design. So our in-house services include engineering, design and drafting, all disciplines, fabrication, both traditional and additive, product design, 3D scanning, architectural design and ESD consultancy. And this broad service offering gives us a broad spread of clients. So we service all 4 of the major mining companies and a lot of the EPCM vendors for mining projects as well. We're also in the commercial construction sector, in retail and hospitality, education and childcare. We're into single residential and multi-res design. We work in the defence sector, in renewable energy, in the equine industry, in marine and port infrastructure and public sectors at local, state and federal government level. Notwithstanding this diversification, our core capabilities are built in mining, with 75% of the business in that iron ore mining engineering, design and fabrication space. And specifically, we consider ourselves brownfield specialists. So we work in maintenance and reliability solutions. Today's focus is on our 3D printing or additive manufacturing capabilities within our mining offering. So our 3D printing services are led by CADDS Group's product design team, and this includes our endorsed brand Innovus. So just to explain quickly the CADDS Group and Innovus dual branding there, we basically developed the Innovus platform as a website to streamline the product purchasing process for our mining clients. So if you see links to the Innovus website on our slides, that's what that is about. And Norbert's team works closely with clients for an intimate understanding of their needs and challenges and to develop innovative solutions that meet expectations and specifications. We use the latest software and tools to create 3D models, simulations, and prototypes that optimize the design and functionality of the products. And this is why additive manufacturing was the next logical step for us in growing and diversifying those services, particularly considering the value that that technology can offer our mining clients when it's integrated thoughtfully into a production process. So we're proud to be at the forefront of additive manufacturing in mining, and we're really excited to share with you today some of the work that we've been doing behind the scenes.
Awesome. Okay, fantastic, Pip. So thanks again for the introduction. Thanks again for the partnership. As Pip mentioned, my name is Richard Elving. I'm the Senior Director for Markforged, coming to you guys live today from Perth, Western Australia, together with my colleague Michael Tuckey in CADDS Group. So for you guys on the call that are new to Markforged, we are an American-based company, head office in Boston. We are known for producing industrial-grade 3D printers, software, hardware that essentially enables the manufacturing industry to produce products in a more efficient way. We are helping companies reshore manufacturing, reduce costs, and address things like labor shortages, right? One of the key things that you might associate with Markforged is that our technology helps you create really, really strong real-world parts on demand. And the Digital Forge platform brings together the 3D printers, advanced software, as well as a diverse range of materials into this really easy-to-use software that's really tailored to seamlessly connect all of your manufacturing processes. A recent launch that we did is the Digital Source platform. So the Digital Source platform for Markforged is really there to help manufacturers produce OEM certified parts where and when you need them. And this is without the hassle and the cost of physical inventory. And this is, of course, one of the key reasons why we are here today, partnering with CADDS Group. For you guys that are from the mining industry, you would be very much aware of the challenges of transporting physical parts and components to mine sites that need to operate 24/7. And this is how we are working with CADDS Group as one of our value-added print service providers. So, hey, I'd like to take the opportunity to ask a couple of questions to Pip and to CADDS Group today. Again, thank you so much, guys, for the opportunity to be here, and thank you so much for hosting us. So I'd like to just start by talking a little bit high level about the mining industry and some of the trends that are shaping the industry, right? So in your view, what are some of the trends shaping the future of the mining industry? And what is CADDS really doing to participate or drive these trends?
Sure, thank you. Yeah, there's probably three things there that are worth touching on. Good old-fashioned operational efficiency is forefront of everyone's minds. A big, we wouldn't call it a trend, but it's definitely a future shaper, is safety. It's always top priority in all of the mining companies' work. And then also, of course, sustainability. We know that that's been a big factor for the last 10 years. So those are probably the 3 points that are worth touching on. Now, as far as operational efficiency goes, our mining clients operate in the same post-COVID economy that the rest of us do, restrictions around reduced cost pressures, time pressures, quality, needing to do more with less. is universal. The main one that we have been hearing a lot of feedback on, especially recently, is cost. You know, price of iron ore is down. Our mining clients, the teams are on site, their budgets are less, and they generally have, you know, they have the same amount of assets that they have to maintain, just with less resources to do it. So one of the things that we are looking at, I guess, for us, 3D printing offers a bit of a value proposition in being able to positively impact cost, you know, not just through cheaper base costs or raw material costs. You know, you've got smarter designs, optimizing designs, reducing weight with fewer components. There's less manual labor than traditional manufacturing. Manual labor is a big one, especially in the WA economy. It's quite expensive, so the more we can reduce that, the better. Less material waste. You've got lower transportation costs. You know, theoretically, your printer will be closer to your point of use, so your supply chain is shorter. And then being able to print on demand reduces, as you just mentioned, those inventory costs that, you know, are just huge in that mining space. The impact on turnaround times as well has a huge impact on cost when you have that much plant and equipment. You know, any piece of kit being down for longer than necessary for maintenance equals massive dollars at the end of the day. So anything that we can do, and again, printing offers opportunities to, you know, the impact on how quickly something can be turned around, as opposed to waiting for an OEM vendor part, you know, from Europe for 10 to 12 weeks. We can print something on demand. The print time is so short. Generally, it's same or next day. Put it on a truck, get it up to site, get it in, get it being used. So you know, all of that sort of works towards site downtime being minimized and ultimately helping that bottom line of cost.
Amazing. So, I mean, you've already kind of touched on this, Pip, but I think everyone on the call would know that the mining industry is going through massive transformation now. There's a lot of talks around, of course, operational efficiencies, but also things like ESG and sustainability, which we'll hear more about from David. But in your views, how is CADDS really responding to these from a strategic perspective to make sure that you're ahead of the game here at CADDS in the mining industry?
Sure. It's pretty much just using everything that we have at our disposal to make sure that we get the best outcomes for our clients. You know, we talk about our business model and operational ethos really of just being a holistic service, offering everything in-house from design, engineering, fabrication to getting it on site. And I suppose the 3D printing technology offers not only massive efficiencies in each one of those categories, it also enables us to integrate additive manufacturing as a whole into our current workflows from concept to fabrication. So when you look at things like design and engineering, the opportunities that it affords us is huge. You've got materials that can be printed now, stainless steels, tool steels, copper, which are all very mining friendly. They're all, you know, used widely in mining design. Part optimization, as I mentioned before, and we're designers at heart, we're going to nerd out over this stuff, but the part optimization is amazing. Design performance, like the internal structures that are just not possible through traditional manufacturing, and, you know, does things like increases the durability and strength of the product, reduces weight massively, positive impacts to durability and strength and ergonomics even, which feeds back into that safety element as well. If something's ergonomic and easier to use, you have, you know, less risk of injury. Rapid proof of concepts is a big one. The shortened time from, you know, thinking of something to testing it to getting it to site is reduced massively because we can print multiple prototypes at a time. It takes a few hours to work out proof of concept. A big one for us is being able to stand behind what we do as well. So we've put a fair bit of effort, and I won't talk about it too much because Anthony will discuss it later, but we've gone to a fair bit of effort as far as being able to certify the stuff that we print. So there is a bit of a lag in between technology and the Australian standards that engineers certify to catching up. Our engineering team is basically working through a series of standard test methods and using first principles engineering that basically enables us to test to ensure that material properties are behaving the way that we're expecting and behaving the way that we need them to behave if we're going to put them in those really harsh mining environments where they're just going to get smashed every day. So being able to do that and stand behind it and say, we can verify this, it's fine. We've also taken things into the workshop and tested them, tested welds, tested durability, tested strength. All of that sort of comes together to, gives us the ability to have massively smarter designs through optimization, test things within the hour, certify what we print, and stand behind how it's all going to be used on site. So it gives us the full confidence in the printed components that we're providing to our clients as part of that strategy.
Amazing. I mean, you've shared so much information here with the viewers today, Pip. But I think it would be great to just hear from you. We've obviously established this partnership. We've established a mining center of excellence here in Western Australia between Markforged and CADDS Group. What was it that enticed CADDS Group to enter into this type of partnership? And how do you see this partnership addressing, besides what you've just talked about, addressing some of these challenges but also opportunities for CADDS moving forward?
Yeah, sure. This is an easy one. So we've been looking into 3D printing for going on 10 years now. So why Markforged and why now? It's pretty much two key reasons. The first one being, so all of that stuff I just spoke about, the confidence to be able to stand behind the products and make sure that we can certify and test what we build before we send it to site. That is only possible because of the technology and the software and the support that we get from Markforged. The printers, the quality of the materials, the IGA software. Our engineers have been working in that to do FEA analysis as well, so that that in part enables the independent certification process. It basically gives us the ability to integrate additive manufacturing into our workflows and reassure our clients that what we produce is going to work, is going to last, and is going to be fit for purpose, which is just a level of quality and support that you can't find anywhere else, to be frank. And the second reason, I think you already sort of spoke about this a little bit, massive one for us is the part libraries. So the digital source. It's a game changer. Being able to print on demand, we can build libraries of parts. We can build them specifically for clients. So clients can literally log on, see their parts library, add to cart. I need that one. It's going to tell them exactly how long it's going to take to print. We can give them a buzz. We'll organise this to be on a truck tomorrow. Do a quick look of it, check it over before it's sent up, get it up there, and all of a sudden we've got cost savings by not needing to hold massive amounts of inventory and components that we only need when things break down. Being able to reduce all of that and really offer that streamlined solution. When something breaks down, you don't need to have a component sitting waiting to go, and you don't need to wait for it to come from Europe for 2 or 3 months. And so the digital force there is really a big one for us.
Thank you.
Libraries are going to change the game.
Amazing. Thank you so much. So we're going to hand over to Norbert.
Right? Norbert and your case study.
Thanks, Richard. Thanks, Pip. Yeah, so I'm Norbert Barbaron, product design manager at CADDS Group. So I look after the Innovos team. Been at CADDS for over 10 years now. And from day one, 3D printing was always on our wish list. It's something that as engineers and product designers, we're always looking into how to bring in tools to help us innovate. And yeah, definitely 3D printing was in there. So initially 3D printing was to help the team to proceed within the design stages smoothly. And once we started looking into it, we actually found how Markforged printers would allow us to do even more than that. And that's where things got excited. So now we do have a Markforged Mark II, an FX20, and a complete system of Metal X. So yeah, here at our Perth office. So now we can do things we couldn't do before. For this event, we're going to share 2 case studies. and just show you guys how we actually integrated 3D printing, additive manufacturing in the design process and run through the design process. So the first case study is about a tool we've designed for one of our major mining clients. It's called the draft gear gauge. So for those who doesn't know, the draft gear is the shock absorbing component that sits in between the train wagons. It cushions the impact generated between the coupler and the underframe, and it just ensures a smooth rail ride. The wearing part of the draft gear is frequently checked and monitored. There's two ways they do this. They do visual inspection or they do hand measurements. So at the moment, they've got guides that helps them determine whether the wear is acceptable. So there are set dimensions that needs to be followed, but it's the way the draft gear sits and where it sits is really hard to access. So they definitely need a tool that does like an all-in-one tool that can measure all three measurements. So the three measurements I'm talking about is the shoe protrusion, the shoe height, and the shoe wear as well. So yeah, the next one, there will be a video that's going to play that will give a detail of that.
We started by really looking into the draft gear and understand how it's currently being checked. Thanks to our in-house scanning capability, we scanned the draft gear to get an accurate CAD model of the profiles. We then processed the data and imported it into our CAD software. This way we could work out the most important surfaces that will interact with the draft gear gauge. The team get together for brainstorming session and came up with a few good ideas to test. Having the 3D printers in-house is groundbreaking. We picked the best ideas, printed prototypes, and tested them to see which work best. In about a week, we had a model ready. We printed critical section to see if they fit and felt right, making sure the tool would be easy to use. Printing was easy. We used the Markforged slicing software, IGA, to pick print orientation, layer height, and infill types. We also made sure it was strong where it needed to be. After printing, we put it together. The printing took about 16 hours overnight, and assembling it took just 15 minutes. Next, we tested it out in our fab shop. It worked great on the first go, meeting all the clients' needs, and was very easy to operate. We did spot a couple of improvements, made some tweaks, and got it even better. Then, that was it. It was ready for the client to try it on site. The client has been using the tool for the past months, and the feedback we receive has been very positive. The tool is compact, light, and sturdy. The client loved the fact that the guides could be locked in place while taking each measurement. The print quality and material strength played a key role during the testing process and was good enough to be used as the end-use product. We can quickly print test parts overnight without slowing down the design work. We've made the design smart so we can upgrade the existing unit to fit new requirements without the need to reprint the whole unit.
Sounds good. There's probably something as well to be said there for, the custom hand tooling is so important for, like I mentioned, safety being front of mind for all of our clients. Custom tools basically allow for safety via ergonomics. So, improving manual handling, improving the speed and efficiency of the task. If you have to go and measure 700 of these in a day, that can get pretty repetitive. So by reducing operator fatigue and minimizing awkward postures or excessive forces that they might normally have to do, you reduce your common injury rates and repetitive strains. And so, yeah, definitely a big one.
Absolutely.
Yeah, so Norbert, you mentioned that to print this part, it took around 16 hours and then say 15 minutes of assembly. Now, prior to your and CADD's adoption to additive manufacturing, how might this part have been made and how long may it have taken?
Sure. Well, the traditional way, you will CNC from a solid block. Again, CNC, depending on availability of the machine and whether we're getting it made locally or from overseas, it kind of adds to the lead time. So doing this project within a month would be very tricky. And when we did it in 2 days, even better. And also the other one would be, so if the client wants more orders, let's say 5 of them, which is not really mass production, but it's not a prototype, not mass production. So we'll go with the vacuum casting technique, which again, you'll have to make a tool and it will just add to lead time. And if those ones, we get them made overseas, it will add to the freight costs and everything. So yeah, it's just having them in-house is just, amazing because we can get this done in a week, even 2 days.
Fantastic.
So our next case study is an AI camera housing that we've done for another client. This project was from a bigger project where we had a camera that was integrated to an AI system. And once we found that this camera is going to be in a workshop environment, we said, all right, we need to get a housing robust enough to last in the harsh mining environment. So first thing we do is literally go to the manufacturer, the supplier of the camera, and find an OEM housing. But we did have, like every mining site, it's tricky. It's not out of the box. You just take a box and put it there. So there are tricky ways to fix those housing in place. So we needed to find one that could meet all our requirements, and it was impossible from the OEM supplier of the camera. So then we look at others, and we could find there were boxes that were housing that were too big, too small. And then we decided, why not just use the 3D printers? We've got them in-house, and that just opens up a lot of possibilities. The team got excited. We did a brainstorming, and the capability of making the housing versatile to evolve and adapt to different sites, different location. That just make this project very unique. So the next video will show how the process started.
After brainstorming, we came up with a system that met all requirements. Within a few days, we designed the housing to accommodate 2 types of cameras and 2 fixing methods. Following guidelines, we ensure the unit was optimized for minimal printing time and support material. We then checked the tolerances by printing a test jig with all the necessary features. The jig helped us identify the best fit for our design before we proceeded to print the first full-size prototype. Once ready, the parts fitted nicely together without any additional post-processing. For added camera protection, we've incorporated an off-the-shelf O-ring and a metal faceplate. The clamp mechanism utilizing standard bolts and nuts and worked flawlessly. Off-the-shelf mag switch were fitted to facilitate quick fixing to metal structures. Mounting attachments could easily be swapped on site without the need of specialized tool. Onyx material by Markforged was ideal for the camera housing as it provided a strong yet light body. The dovetail connection allows us to design and make standard attachments and swap whenever needed. There's a special insert for the camera that will work with future models.
Fantastic. So, Norbert, you've mentioned to me previously that this camera housing actually accepts 2 different camera modules. Can you speak about that and how the flexibility of additive manufacturing has facilitated that kind of design?
So from the start, we basically used one of the camera, and we found that we needed another camera that had a LAN support in there. So because we didn't want to reprint the whole housing, we designed the housing in such a way that it's got like an insert. So the insert allowed us to swap cameras while doing a site trial. So as you can see here, this one can fit in there. So it's the bigger camera. And then once you remove this, you've got an insert and you can put a smaller camera in there, and that fits perfectly into it like this. So this allows us to take it on site, try different cameras, but also open the door for future cameras. So if the supplier decides to create another camera, as long as it fit within the footprint, we should be able to design on the fly an insert that adapts to the new camera. And that's where additive manufacturing is very handy, because you can have a 3D model of the camera and quickly design it, print it overnight, and test the next day without any delays.
Fantastic. Very good.
Great. All right. Thank you, guys. So next we're going to hear from our engineering manager and principal engineer, Anthony Snowden, and our student engineer, Matthew Reed. They're going to walk us through the technical work that the team have been doing behind our independent certification methods. Now, we're going to play some video footage that we've taken of some of the actual test work we've done. So we've basically taken printed parts and then we're testing the material properties for anticipated behaviour. And I just wanted to give a little bit of a content warning / apology for the video quality in advance. Looks like whoever was filming had a bit of a hard night out the night before, and they've got shakes a bit. So if you get motion sickness, you may want to look away. But yeah, very, very interesting videos.
I'm Anthony Snowden, Engineering Manager at CADDS.
I'm Matthew Reed, and I'm a student engineer at CADDS. At CADDS, we engineer using first principles, which involves breaking down complex problems into the most basic, foundational elements and then reasoning up from there to find solutions. It requires a deep understanding of the fundamental laws of materials and physics.
As the work of traditional engineering gravitates towards tools like finite elements analysis, which are built upon decades of testing and mathematics, emerging technologies such as 3D printing cannot rely on the work of past practices the same way other engineering fields do. First principles then become essential for the development of 3D printed products, seamlessly integrated by CADDS, backed by 30 years of experience.
It begins with attaining the strength properties of our 3D printable materials, notably stainless steel and Markforged's Onyx, a microcarbon fibre-filled nylon composite plastic.
The materials testing CADDS undertakes involves a rigid adherence to the relevant codes and standards of the strength of materials. By using credible resources such as ATSM, standard test methods for flexural properties of unreinforced and reinforced plastics, and ASTM E8, standard test methods, CADDS ensures precise data and universally dependent material properties.
From there, the methods of first principles can be built upon a rigid foundation of materials sciences to provide accurate models, leading to an authentic understanding of how our 3D printed components behave in real-world applications.
CADDS has a team of dedicated engineers who have a strong and holistic understanding of Australian standards and the means to design under compliance to these codes.
As part of our work using Markforged 3D printing, we pride ourselves on the ability to utilise additive manufacturing alongside the standards of Australia to deliver complex parts that are tough and reliable.
Great, thank you. Now we're going to hear from Chris Edwards, who's our fabrication workshop manager. Chris has been doing some of the fabrication test work that we've been undertaking on our printed parts. Yeah, we've got a couple here that he'll walk you through how he's been testing them in a moment, but I'm not sure if you can see there. So they were able to, this was a lug that we've been able to weld, and they've cut straight through that, and you can just see there, like, not only the internal structure that's that's been able to happen through 3D printing, but also just the solidness of the weld. It's really important for us to be able to test things like that. So Chris will explain a bit more.
Hi, I'm Chris Edwards, Fabrication Manager here at CADDS. Over the past 6 months, we've dedicated ourselves to the thorough testing and experimentation with components produced on the Metal X by Markforged. Both traditional fabrication methods and 3D printing have distinct advantages, making them suitable for various applications and scenarios. Initially, it took some time to embrace the concept of integrating metal 3D printed parts into traditional metal manufacturing processes. However, once we began implementing these parts in real-life situations, it became evident that this is a real game changer. The selection between the two methods rely on factors such as project-specific requirements, desired production quantities, budgetary constraints, and consideration to lead time. Often a hybrid approach combining both of these processes is utilised to harness the strengths of each process. In our experience, lead times for complex 3D metal printed parts significantly surpass those of traditional CNC machine parts, with 3D printed parts often available the following day. Traditional CNC machining typically involves starting with a billet of material and then removing that material. Complex parts often necessitate the input of multiple CNC machines. In contrast, 3D printing minimises material waste and offers the capacity to create intricate parts without the need for numerous processes. We've conducted thorough testing on the weldability and durability, in particular stainless steel. Utilising various processes such as MIG, TIG and arc welding, we found that the processes performed remarkably well. Furthermore, we've welded and evaluated numerous combinations of the standard 316 stainless steel items, such as extrusions and plate work, with 3D printed parts, revealing minimal differences in the weldability between the printed parts and traditional stainless steel extrusions and plate work. This innovative technology adds another dimension to our capabilities, enhancing what we can provide to our clients. By shifting our perspective to explore how this technology can enhance traditional fabrication methods, we unlock a realm of possibilities for the creation and process optimization. This enables us to deliver top-notch products with minimal turnaround time, opening doors to new opportunities of efficiency and quality.
Great. Okay, so now we're going to hand over to David Martin from AI Group to walk us through the 3Ds. So David, please take over.
Good afternoon, everyone. I hope you can see me. Can we have confirmation? It's always, you ask three things usually in these kinds of meetings. Can you see me? Can you hear me? And is that your small child or dog quietly walking around in the background? So can everyone confirm that you can see and hear me clearly? I'm guessing that's the case. So I'm about to share with you some slides that are provided from Australian Industry Group. And they are focused on some of the key trends and analysis that are coming out of our most recent survey with regards to our members. So Australian Industry Group, to give you some background, is a peak industry association that represents the interests of over 60,000 companies. And the reason why I thought some of the information that I'll be sharing with you today might be of interest is that there are probably two different types of people who are actually listening into this fantastic opportunity today. Either people who are the technical specialists and need to understand where these purchases of these critical assets are going to fit into the overarching strategy of the organisation, or you're running one of these key organisations and you're probably trying to understand what's happening out there with regards to your peers on the ground. So I just thought to share some of the key findings that we had from our most recent survey, and also from a key diagnostic that that Australian Industry Group has called FutureMap. And FutureMap is a diagnostic where we do workshops with industry of all different types across Australia, with regards to how to position yourself strategically for the future ahead. And in particular, our most recent one has a specific emphasis on net zero. But overall, we've now worked with over 1,200 different manufacturing companies, mining companies, and a range of different companies to get an intimate understanding of what's going on. So when we look at our members, and we've most recently gone out to our CEOs of our membership, these are the key challenges that we're actually seeing on the ground. They're still quite weary post-COVID. They're challenged with red, green, and grey tape. Red tape is the normal red tape that you see when regulation comes on board. There's an increasing level of green tape with regards to ESG and sustainability reporting. And grey tape is when you're a smaller organisation that sits in the supply chain of a larger one, and a lot of the regulatory burden has been passed on to you. They're asking you for critical data. I won't go through each of these because I'm conscious I only have 5 minutes of your time, because there's going to be some fantastic questions asked at the next panel. But I just thought this is what our observations and what our research and our surveys have both shown are the key things that are on the minds of most people in most sectors, mining as much as manufacturing and everybody else. And I should confess too that I'm an ex-geologist by trade, and that I have a deep love of all things 3D printing. I used to work in nano fabrication in a previous life. Just with regards to net zero supply chain pressures, I mentioned that there is actually a strong move to carbon accounting and grey tape. What is really interesting is that if you are looking at how to actually position yourselves and why the technologies you're seeing today are actually important, it's because some of these larger organisations have an expectation that you are going to be able to provide them key data. And there is no decarbonisation without digitalisation. And digitalisation, in many respects, these cutting edge pieces of equipment today also provide a wealth of data and information that can be used for your reporting requirements. And that leads to the third thing, which is diversification of business models and understanding how you fit into the scheme of things in a couple of years from now. So when we talk about the 3Ds, we simply say there's no decarbonisation without digitalisation, taking on board novel new technology that enables you to position yourselves moving forward. We also wanted to share some of the industry sentiments that came out of those surveys and information we're going. One of the key things is that at the very bottom of the page, you'll see on the right-hand side, there is a very strong emphasis, interest and focus by CEOs and a whole range of people who are looking to technology and innovation to assist them during this challenging time. Input costs, the level of uncertainty and industrial relations are the main reason that CEOs and people who run these organizations are concerned. And they're very, very much looking to technology to achieve efficiency gains with the lack of skilled people around to access, and drive efficiencies and productivity through their organizations. And we also note that when talking to our members, and we've got over 60,000, as I said, that we work with, businesses are really looking to integrate new technologies into their way of doing things. Primarily, they're looking at innovative, active technologies, and those who actually bring on new technologies actually are seen to be more productive, have increased levels of revenue, and tend to be able to weather the storm with regards to the shocks and challenges that people find themselves in today's marketplace. And as I said, if you'd like a great thing to read, I'm happy for these slides to be shared with anyone who's interested. If you'd like to know more if the impact of decarbonisation and why there's a need for digitalisation and business model transformation and the technologies that you see and how they fit into that, this is a fantastic article that I highly recommend by an Australian person who is got deep links actually to the mining sector and making some of the more dumber equipment smart through the use of additive bits and pieces to kit on machines. So as I end, I just always recommend everyone to consider their business models moving forward and how the technology actually fits into this. Many people in the C-suite that you might be engaging with about these purchases are very much focused on the here and now and very much about how to navigate the challenges of the future ahead, whether that is the biggest of the big companies or the smallest of the smalls. They're looking at anything that can help them with regards to productivity gains and also efficiency gains and the ability to provide people in the supply chain they work in a measure of clarity about where things are at, how they're progressing, and if they can mitigate the reporting requirements to some of the new regulations that are coming on board. So the final thing I was going to say is a lot of the discussions today are about technology, but one of the other key things that's come out of our most recent surveys, and this will be the last slide, I believe, is there's a critical need to make sure there's appropriate skills and training that sits alongside the purchase and use of these new bits of equipment. Our research and our feedback from members and some of the recent workshops that have been running is that the board and executive absolutely need to focus on the strategy of the organisation and how this new technology fits into that. Middle management needs to be empowered to execute and make sure they're across the reasons why this is happening. And those who work on the shop floor and in amongst it need to understand this is about enhancing their roles, not taking their jobs. So I thank you very much for the opportunity to present these few slides today and share what our members are telling us and what some of our most recent diagnostic data is telling us about the critical importance of bringing data in and with regards to these technologies you've seen today. But it's been an absolute pleasure being able to share with you today, and I'll hand back to the panel. Thank you.
Awesome. Thank you so much, David. That was really informative. That brings us to the end of our scheduled programming. I've always wanted to say that. Now we're going to jump to some questions from the audience. But first, I just wanted to say thank you so much to everyone for joining us today. Really appreciate your time dialing in. And if you do have any questions, please pop them through the chat, or the slide that we're going to put up at the end, there you go, has got a couple of email addresses on it. You'll also, all registered guests will get an email, a follow-up email after this is finished with contact details and a link to the presentation as well. So we'll go to our first question, which has come through. I think someone's asked us to just walk through the printers that we have got, that we have behind us here, the 3 different printers. So
First question, guys. So what 3D printers does CADDS have, and can you guys give us an overview of this?
Yeah, so the first one is the Mark II. This is the baby printer, but it does a lot of work. So at the moment, we are printing a client's project. It's a handrail attachment with continuous carbon fiber, continuous fibers on top and bottom. So this one is in onyx pure and continuous fiber. So this machine can print PPU, nylon, precise PLA, carbon fiber, fiberglass, and Kevlar. And yeah, so other one, this is the smallest machine. The next one is the FX20, which is this one here. Here you go.
very important work.
So the FX20 is the industrial flagship for Markforged there. It can do pretty much the same, and on top of that we can print Ultim. Yeah, and the next one, which is currently printing, is the Metal X. So at the moment we're printing a, if you can just switch there. So this is a combination of onyx, stainless steel, and using off-the-shelf fixtures. There you go. So this is really pushing boundaries in terms of what we can do here. So yeah, it's stainless steel, onyx, and yeah, put together with machine keys.
Really great example of part optimization for that one. That's actually a mining part, and if we showed you the photo of the original, you probably wouldn't recognize it. This replacement part is so much lighter, smarter, more durable, and again, you know, we were able to print it and put it together in a matter of hours and days rather than weeks and months.
Yeah, that's it.
Fantastic. So, hey, next question from the audience here, guys, is that you mentioned the sustainability, right? In what ways is additive manufacturing actually helping CADDS with sustainability efforts?
Yeah, sure. So sustainability is obviously a big one in mining, you know, with the 4 major mining companies all having announced that they're going to hit net zero by 2050. So we find additive manufacturing is really great, even just in a passive space as far as reducing carbon footprint goes. So, you know, the precise production and specialized designs lead to reduced material usage. The efficient manufacturing process equals energy savings actually during the process. Better designs generally find that they take less energy to use as well. on-demand printing, gives you that the printer being much closer to the point of use. So you remove a lot of your carbon footprint as far as supply chains go, to do with, logistics and distribution. Shorter supply chains at the end of the day also equals more support of local communities. So it's not just a great active tool for designing to reduce your carbon footprint. It's almost like passively by printing something and sending it to site, you're already cutting down so much on your carbon footprint.
Awesome. Okay, and then Hank, we have the next question here from Ed. So Ed is asking, how accurate are these printers? And on top of that, do we believe that wouldn't it be cheaper to produce some of these parts using traditional methods like MIM or injection molding? So two questions. One, how accurate are these printers? Maybe Michael suitable for this. And two, is it not cheaper to just use traditional methods and ways of manufacturing like injection molding from Ed?
Yeah, well, thank you very much for your question, Ed. So to answer the first part of your question, how accurate are these parts? Well, this case study part from CADDS here is a perfect example. So this is an accurate measurement tool tailored specifically for the application of measuring. And this has been printed on this big beast behind me here, which is the FX20. So this machine is accurate down to 0.1 of a millimeter, essentially, in the Z-axis, and then 0.15 of a millimeter in the X and Y axis. So very accurate, Ed. So the other question Ed had was around the cost of manufacturing parts. So to answer that, essentially, if we look at, say, large-scale plastic manufacturing, if we could think about the kings of large-scale plastic manufacturing, and that's Lego. So when Lego make a part, they will make it by the million or by the hundreds of millions, for example. So they employ the technique of injection molding. So they'll make a steel die and then inject plastic into that 24 hours a day until you've got that new race car or whatever it was you're looking to buy. However, that's not necessarily the most cost-effective way to produce something if you, in the case of this part again, only want 5 of them. All right, if we only want 5, we don't want to go and spend $50,000 making an injection mold. We could, but it's not going to be the most cost-effective way. If we want 5 of them, we fire up to the FX20 here, and we can produce 5 of them inside, say, 3 or 4 days at very minimal cost. We're only essentially paying for this material that gets used.
Yeah, that's right. Michael's hit it pretty much spot on. It's the economies of scale. So, not every project will necessarily be cheaper with additive manufacturing, but there are a good lot of use cases where, like you said, using economies of scale, if you only need 1 or 5 or even 20 of something, it definitely is a lot cheaper to use that additively.
The other thing I want to touch base on is getting in the market as early as possible. So when you're doing mass production, you'll take maybe 2 to 3 months to get tool ready and have your stock coming here. Whereas now you can get in the market as early as possible, and later on and build on that marketing, branding, and then take your time and then get into the market and sell mass production later.
That's a good point as well. As we know, time equals money. So the faster that we can cut the design and production time down and actually get that part to site faster is also a cost reduction.
Awesome. Okay. So hey, the next question here comes from Joel. So guys, please continue to send in your questions here. So Joel, he's asking Michael, what about 3D printing threads? Well, here's an example of a component. So is it possible to 3D print threads on a Markforged printer?
Yes, absolutely. So both our MetalX metal system as well as our composite systems are capable of printing threads. Now, The practicality of that is essentially you're only going to want to print down to say M4, M3 type size threads. That's on the small scale. Then on a larger scale, if you can fit it in the machine, you can print it. Now, so essentially that's going to bring us, up to really, really large threads. But essentially, yes, the answer to that question is absolutely. And that really dovetails nicely into the accuracy that we spoke about earlier on, because obviously a thread is going to be have a requirement of being very, very accurate.
Great. The next question here also comes for Pip and for Norbert, right? We have one of the viewers asking about where do you guys see the future of applications and various components in the mining industry? So today you've talked about AI housing, you've talked about a few prototyping examples. Where do you guys see additive going, and do you have some other projects that you can tell us about?
Oh, we could tell you about them, but we'd have to kill you. I think for us, one of the biggest things is going to be getting those parts that are being used every day to site faster. The AI camera housing is a big thing. There's obviously that push to make sure that we digitize as much as we can, which leads into where we've sort of got, we call it VAM, Visual Asset Management, which is this push to digitize, and that sort of ties in nicely with the additive library for parts and things like that. You can literally, instead of going to site and locking onto an asset and checking it and finding a part and measuring the part and calling the OEM vendor and getting the part sent out, that can be someone in Perth who's asset monitoring from a digital model from Perth. So you reduce your site time, you reduce safety, less people on site is safer, obviously. And, being able to look at that, find the exact model or the part of the thing within the visual asset management model, and then jump online, order it and send it out. So you're essentially doing the monitoring and the checking and the ordering instead of that being a manual process being out on site. You're actually doing that remotely online through digital libraries and digital asset.
Fantastic.
So that would be one of the main ones for us that we're working on.
So, hey guys, just before we wrap up today, Pip and Norbert, maybe you can share with the viewers, how do the viewers here that are looking for services or looking to leverage CADDS, like how do they get in touch with you?
Just come on down. We have, if you're specifically interested in the Print 3D service offering, we've got our print3d@cadds.com.au email address that people can jump on. That will be sent out to everyone in the thank you follow-up email as well. Very easy to remember our email addresses, first name dot last name @cadds.com.au. So Pip Smith @cadds.com.au, Norbert Baburam @cadds.com.au. And we're all under one roof here. So just reach out to us. And if there's another service offering that you're interested in, we're more than happy to put you in touch with the right person within our team. Yep.
Excellent. Well, guys, thank you so much for dialing into today's Markforged CADDS webinar. I hope it was valuable and that you learned something. I've truly enjoyed it. I'm sure you have as well, Michael. And
Absolutely.
we look forward to welcoming you guys on the next one. So thanks again.
Great. Thank you.
Thank you.
Thanks.